G'day guys, and welcome to another segment of my Cisco ICND 1 practice exam questions for the CCNA. And today's topic will be about subnetting. I'll be honest with you guys, I was not a big fan of it. I didn't do that well on it, but hopefully I'll be able to go alright today. Yeah, I absolutely didn't really like it very much at all. It's a pretty flimsy topic to get your head around. You really need to have a lot of practice at it. To do it manually, you can do it automatically online these days, but yeah, not my favourite topic to talk about. It's a big one today as well, so hopefully we can stick through it. But it'll be interesting to see how we go with this one. Hopefully it helps you guys out. We'll start off with 86. You are designing the IPv4 address scheme for the network. How do you calculate the broadcast address of a subnet? Now, with this one here, I'll probably just go through, explain the answers. I will say that there will be a lot of needing for you guys to practice before you actually sort of have a look at this, but you can go through it anyway, and hopefully my explanations of it will sort of help. The answer to this one's B, set all host bits to 1, and in order to calculate the broadcast address of a subnet, all host bits have to be set to 1, and then it's converted over to decimal. So question 86, you are designing the IPv4 address scheme for the network. How do you calculate the broadcast address of a subnet? I'll probably do more of an explanation for why the answers are the answers, as opposed to sort of going through, is it this one, is it this one, is it this one, otherwise the video will go on for 3 hours. So the answer for this one is B, set all host bits to 1. As we know, or may not know, so there's 32 bits overall with 4 lots of numbers. So there's 4 lots of 8, make 32, and if they're all set to 1, they're all 255s essentially, which is a fundamental part of the subnet mask. 87, your manager would like you to subnet the 129.65.0.0 network into different networks. What is your new subnet mask? Dealio with this one is C, 255.255.224.0, and to create 6 new subnets, you need to create 8 subnets by borrowing 3 bits from the host ID portion of the subnet mask and converting them to subnet bits. On to question 88. What is the subnet mask of 135.44.33.22/20? The /20 or /number X basically means how many times is 1 represented at basically the start of the 255 sequence or the number sequence. So there's obviously 32 where there's possible ones to put there. So in this case we've got 20. And the answer to 88 is 255.255.240.0. So the -20 is the CIDR notation for the number of bits that are enabled in the subnet mask. So as we can see here, these would all be 1s, these would all be 1s, so that would make 16, and then 4 more out of the next 8 bits makes it 240. So the difference between 255 and 240 would be the last 4 subnets, so the last 4 bits of that section there, which makes it 240. I can get relatively simple terms of subnetting down pat, but the tougher ones seem to get me for some reason, and this is probably all pretty straightforward. 89, you're designing the IP address scheme for your network, and you need to subnet the 142.65.0.0 network into 12 different networks. What is your new subnet mask? The answer for 89 is 255.255.240.0. And a bit of an explanation behind this one. To get 12 subnets, we need a subnet with 4 bits, so 2 to the 4 is 16 networks. And we started with class B, which is the second tier. We got 128 network to 191, and obviously class A would be 1 to 127, and the default subnet mask of 255.255.0.0. And then to add 4 subnet bits, need to make a new subnet mask of 255.255.240.0. Question 90. How many host bits are needed in order to support 1010 systems on the network? So this one, we need to get a bit of maths out. And the formula for that is we've got to have the host bits, 2 to the number of host bits, and then -2 The -2 is the broadcast address at the end, which is a 255, which can't be used as one, and then the first one, which is allocated out to a gateway. So in this case, we need 1010. So in this case, the answer is 10. I'm going to allocate 10 host bits. So it's 2 to the power of 10 minus 2 equals 1024 minus 2 equals 1022. Any more or less is too many or not enough. Question 91. How many mask bits are needed in order to create at least 20 subnets? So again, this is a bit of 2 to the power work again. Just a matter of how many times to the power of 2 make at least 20. In this case, it is C5. So if we go 2 to the power of 5, that equals 32 subnets. If we go 2 to the power of 4, it's 16. And 2 to the power of 6 will be too many. So yeah, once again, it's just a matter of having enough that it covers the base, but not too little, not too many. It's pretty similar to the last question. 92. You are designing your IPv4 address scheme. How do you calculate the network ID of a subnet? In this case, the answer is set all host bits to 0. The answer is A. And the network ID for a subnet can be calculated by having all the host bits set to 0 and then converting to decimal. 93. How many hosts can exist on a network with the address of 180.45.10.20 under a -20 network? So again, this one's a little bit of mess, and that's basically what subnetting is. So if we have a look, we've got a /20 network, which means there's 12 more bits left because there's 32 bits out of a total address. And if we do 2 to the power of 12, again it's a bit of power work again, that equals 4096, but we've got to also account for the host bits, we've got to account for the broadcast address and also the network ID. So we've got to take away 2 from that, and then that means the answer will be 4094 C. Question 94. How many subnet bits do you need to create 6 networks? So 2 to the power of 2 won't be enough, that'll only equal 4. But if we go 2 to the power of 3, that'll equal 8, so that'll be about all we need. 3 subnet bits will allow us to create between 5 to 8 networks. Question 95, which option on the Cisco router indicates that you can use the first and last subnets of a subnetted network? This is a bit of a command in this case, and it looks like there's one that looks like a command, which is IP subnet 0. And this command is just the default command on Cisco routers, which allows you to use the first and last bits of the subnets when subnetting. 96, moving along, which of the following subnet masks match to the CIDR notation is correct? And again, it's just about a little bit of math here, but working backwards, reverse engineering to get to the answer nice and quickly. We'll go with A, so 255.255.255.224. /27, so there'd be 5 more bits. Well, I guess an easy way to look at it, so you got these 3 lots would be 8 each, so 8, 3, 24, and then the first 3 from the last 8 bits are covered, so that's 128 plus 64 plus 32, so they're covered, and then the difference between 255 and 224 is 5. Well, /5. 97. You are designing a network with subnets of variable sizes. In the figure below, identify 2 problems with the design. So we're getting all practical here. And just having a look. I'll just go to the answers if you like. That'll be nice and easy. Then I'll explain it from there. Subnet C does not have enough addresses, and computer A is assigned an incorrect address, so we'll just have a look at that one again. Subnet C, so we'll just have a look at this one. So in the network diagram, subnet C requires 22 users, but using a subnet mask of -28 only allows for 4 host bits, which means only 14 valid addresses. 2 to the power of 4 is 16, and then -2, which is 14. So there wouldn't be enough addresses to support 22 users. And then the second part of the issue is computer A has a wrong IP address. The subnet mask of -25 tells us that the network is subnetted because of classable IP addresses using -8, -16, and -24. And in this particular instance, they're looking for addresses broken into two subnets. With the 25 notation, we're dealing with one subnet that has an increment of 128. This means that the network IDs are 0 and then 128. And then the network diagrams are showing us that the subnet ID is 202.45.67.0, and that would mean all systems on that subnet must be between 1 and 127, because 128 is the value of the next network ID. I hope that made sense. Question 98. Your system uses the IP address of 145.68.23.45 with a notation of 25. How many systems are supported on your network? So looking at this one, we've got a notation of 25. The difference between 25 and 32 is 7. So our old formula of 2 to the power of 7, which gives us an answer of 128 down here. But we've got to take into account the network host ID, and also we've got to take into account the broadcast address, which can't be used. So that means the answer would be A, 126. Question 99. The fast Ethernet port on a router is assigned the IP address of 131.107.16.1/20. How many hosts can exist on the subnet? Funnily enough, we had the exact same question before, so we get the exact same answer of 4094. So there's 12 host bits. So that means we've got 2 to the power of 12, and then minus 2 again, and we get the same answer of 4094. Question 100. You want to assign your serial interface the third valid IP address in the second subnet of 192.168.2.0/26. Which IP address would you use? So this is our first network, of course, where 6 bits out of 32. 2 to the power of 6 is 64. So this would be the start of our second network. This would be the host ID, 64. So the first valid would actually be 65. So it's 65, 66, 67. So the answer would be D, since that is the third valid IP address after the second subnet. Question 101. You are designing the IP address scheme for a branch office that needs to support 92 systems on the network. What should your subnet mask be? Now again, we'll just have a look at how many host bits will we need to get to 92. And if we do the mathematics here, we know 7 out of 8 host bits get 128 or 126 valid addresses. If we do 8, we get 192, which is too many. If we do 6, we get 64. So we'd have to do 7 in this case, and if we write down the notation, we'll have approximately we have 8, 16, 24, 25, so it'd be a /25 network. And if we convert it all to decimal, we get the answer as B. 102. What is the minimum number of host bits needed to support 510 hosts on the network? So again, we get now powers out. As we just saw then, 2 to the power of 7 will get us to 128. And I think any more than 10, we could be in a bit of trouble. So the answer for that one, if we just look at doubling, so we go 2 to the power of 7, we get 128. 2 to the power of 8, we get 256. And then we double to 2 to the power of 9, we get 512. And then we minus 2 because of the network ID is 1 and the broadcast address. So that would mean the answer would be 9. 103. You wish to subnet 137.15.0.0 in order to support 8,190 hosts on each network. You wish to use the smallest subnet size to support this number of hosts, which will be the new subnet mask. This one's a little bit tricky. We need to borrow 3 bits from the third octet in order to have, so 3 bits, wherever we're going. We need to borrow 3 bits from the third octet in order to have each subnet support 8,190 hosts. So therefore, the new subnet mask is 255.255.224.0. Question 104. How many hosts can exist on a network with the address of 201.10.20.30 and a notation of 27? So we've got 5 bits left, and if we do 2 to the power of 5, we get approximately 32. 2 to the power of 4 would be 16. Yep, that's correct. And then we're going to take away 2 again, get our mass out, and we have 30. 105. With the goal of preserving addresses, which of the following subnet masks would you use to create a subnet of up to 60 hosts? So with this question, we can write out all the ones and zeros again. So if we need 6 host bits to support a minimum of 60 hosts, because 2 to the power of 6 is 64, minus 2, which gives us 62 valid IP addresses. So if we go with 2 to the power of 6, that means there's approximately 2 bits that are being used and 6 that aren't. So we do 128 plus 64, which gives us 192 in the last area of there. So B would be our answer. Question 106. You have a system whose IP address is correctly configured for 198.45.6.87/27. You are now responsible for assigning an IP address to the router. Which of the following IP addresses should be assigned to the router? This is a really tricky question. So I'll just read out the explanation I have in front of me. The answer is D. Now, to explain this, the first step to figuring out which choice is on the same subnet, we need to determine how many bits are used to create the subnetted example. In this case, because it is a class C address, it should only have a -24 indicating the number of bits enabled in the subnet mask, which is a subnet mask of 3 lots of 245s and then a 0. Because this is a /27 network, you know that there are 3 additional bits that have been enabled in the subnet mask. So that's 3 on top of the /24 to create the subnetted example. Step 2 is to look at the value of the last subnet bit that has been enabled and use this as the increment value, which in this case is 32. Once you know the increment value, the third step is to list out all of the subnet network IDs and determine which IP address given in the question refers to. In this case, the network IDs are 198.45.6.0, 198.45.6.32, 198.45.6.64, 198.45.6.96, 198.45.6.128, and so forth. The address given is 198.45.6.87, and because .87 falls in between 0.64 and 96.96, we know that the address is on the 198.45.6.64 network. So the answer to which IP address you would assign to would fall between .64 and .95, and this is because it can't be .96 because it's next to what we assign the next network ID. The answer cannot actually be .64 because it is reserved for the network ID as previously mentioned, and all host bits are set to 0 in that case. It cannot be .95 because that is a broadcast address for the .64 network, so you need a number from .65 to .94, and .94 is the only value in the list of choices that it gives on the subnet. So yeah, very tough one. Don't expect you guys to understand that. I barely understood it myself. Question 107, what is the network ID for the third subnet of 220.55.66.0 with the notation 27/27 network? So we know the first network is that, and now we've got to figure out how much is it incrementing by. So we've got 5 host bits left. So 2 to the power of 5 is 32. So that'll be our second network, and our third network will be the bottom one, D64, since it's incrementing by 32 based on the amount of host bits left in a subnet. Question 108, the 24.60.32.20/11 network address is located in which of the following subnets? So if we have a look, we have here 11 host bits that have ones. So we've got 8, which would be 255, and then we've got 3 after that, and which would be 192 plus 32, which is 224. And the difference between 255 or 256, that it can be sometimes, is 32. So it would be A. The 24.32.0.0 network. 109, you need to assign the fourth valid IP address of 107.53.100.10/12 network to the fast Ethernet port on the router. What address would you use? This one requires a bit of explanation as well. To figure this one out, we need to first determine the subnet range, and we can do this by looking at the address first and determining that it is a class A address, and then looking at the number of bits used in the network, which we have here, 12, and there's at least 4 bits more than default class A, which is normally about 8, or at least 8 or under. This means that the network is subnetted, looking at the value of the last subnet bit, the 4th bit, which is 16, and it becomes the increment for you to determine the network IDs. So the network IDs 107.0.0/12, 107.16 down to 64 with a .12 network notation. And then we need to identify where the address in the question falls, and is between 107.48.0.0 to 107.64.0.0, because 16 is the difference when we do our calculations here, because the answer is 240. Oh, sorry, not the answer. 240 out of 255, 256 has been allocated. So the difference between that is 16. And yeah, once we look at that, so the IP address supplied in the question is 107.48.0 network. And once we get the ID, we just count 4 addresses up, and we get an answer of 107.48.0.4. A little tough one for us. 110, a network administrator is working with the 195.34.56.0 network, which has been subnetted into 8 networks. Which of the following 2 addresses can be assigned to hosts on the same subnet? This is a little bit tricky once again. So we need to create 8 networks. So how many subnet bits do we need? We need 3, which gives us 8. 2 to the power of 3 makes us 8. And then 3 bits, we need to get a new subnet mask in binary. And looking at the networks here, yeah, I'll just give us the answers here. 195.34.56.35 and 195.34.56.58. And the best way to explain this one, if we figured out the incremental value, which is 32, so we would initially have, so going from 32, we need to borrow 3 subnet bits, so that gives us 35. Go another 32, that'll have the starting of the next subnet, so then 58 would be the next available address in that question. More diagrams. 111, use the network diagram shown in the figure below, and having the goal of making the best use of your IP address space, which of the following represents the address scheme you would apply to the Toronto office. Looking into this one, so we just need 27 users, so looking at our little formula again, we go figure that 2 to the power of 5 is equal to 32 minus 2 gives us a max of 30 usable hosts, 32 all up. And if we take 5 bits off of 32, we get a network of /27. 112, what is the network ID of 190.53.159.150.22 network? So we'll look at the answer of this one, and it is 190.53.156.0. So in this example, a large number of networks being created while 6 subnet bits are being used, and /22 bits minus 16 bits used by default is 6 extra bits that are being used. And with those 6 bits being used, this makes an increment of 4. And the network IDs are going to increment by 4, starting at 190.53.0.0, and it'll go 4.0, 8.0 is network 3, and we'll continue on. And then the IP address in this question in particular falls just before 190.53.160.0 network, so that means it'll be part of the 190.53.156.0 network. 113. Which of the following statements are true of 205.56.34.53/28 network? and we're going to choose 3 on this occasion. And we'll look at the answers here. C, the network ID of the subnet is 205.56.34.48. F, the network is subnetted, and the broadcast address of the subnet is 205.56.34.63. And with H, we've got Class C address, and default subnet mask would be /24, but in this case we've got /28, so there's extra 4 bits that have been borrowed, subnet bits. And the value of the last subnet bit is 16, so the incremental of the network IDs will give us 0, 16, 32, 48, 64, and so forth. So the IP address given in this example ends with 53, so it would be a part of the .48 network. If we went any further, it would be .64, which wouldn't represent it. 114, which is the broadcast address of 107.50.100.10/12. So in this case, we've got a Class A address here, as we can see. Anything from 1 to 128 or 127, I believe, is Class A. But we have 4 extra bits borrowed, as we can see there, which makes the subnet mask a /12 network. The value of the last bit subnet is 16, which is the incremental value, and this will create network IDs of 0, 16 to 64, so forth. So the address in this question falls into network 4, which would give us a broadcast address of 1 less than next network's network ID, which is 107.63.255.255. 115, you need to assign the last valid IP address of 199.45.67.139/26 to the serial port on your router. What address would you use? So in this instance, we have a Class C network, and we've also borrowed 2 extra bits, as we can see there. So Class C networks anywhere between 192 to another bigger number. I'm going to say 224, and go with a guess there. So we borrow 2 extra bits, and that'll mean that the last bit subnetted is 64. So 128, which is at the start of the subnet or subset, and the next one would be 64. So I'd go in increments of 64, and the question ends in 139. So it would be, by calculation, it would be on the 128 network, going in increments of 16. So that would mean our answer would end up being 199.45.67.190. Question 116, what is the last valid address for the subnet of 2220.55.66.64/27 network? And the answer to this one is B, 220.55.66.94. The last valid address of the 64 subnet in this example ends up being 94, and to figure this out, the next network ID would have been 96 as the value, and the number before that would have been 95, the broadcast address, so that means that 94 would be the last valid IP address. 117, which of the following addresses exists on the same network, knowing that all systems have the subnet mask of 255.255.240, and we've got to select 2. The answers to this one are 195.34.56.7.30 and 195.34.56.7.17. 118, which of the following statements are true for 190.88.122.45/19 network? And we've got to choose 3 in this case. The answers we have here, the first valid address of the subnet is 190.88.96.1. The network is subnetted, that generally seems to be a common answer, and the broadcast address of the subnet is 190.88.127.255. And finally, 119, which of the following subnet masks would you typically use on a WAN interface to make the best use of address space? A WAN link only needs 2 IP addresses available, so to get 2 IP addresses available, we just need 2 host bits, which gives us 4, and then we take away 2 again in that formula, which gives us 2 valid IP addresses, and so the subnet mask would look basically have 32 2s. which means there's 32s, and then there's 2s remaining, which gives us an answer of 255.252. And that is all, folks. A pretty long video, that one, and I'm not fantastic at subnetting by any means, and I certainly recommend looking at other videos and tutorials on how to subnet and the general foundation of it. Certainly reading the Cisco textbook would certainly help out as well. It's a lot to get your head around, and there's so many ways I can word things, and a lot of it's just a matter of mixing numbers up and knowing values between bits and network numbers, as we can see, prefixes there. And that's how I'll say it's a pretty difficult concept to get your head around if you're not too familiar or good at thinking ahead with maths. But yeah, look, plenty of time practice on this one, guys. I certainly recommend that. Thanks for watching anyway. I've been reasonable help, but I haven't been fantastic, that's for sure. Thanks for sticking around anyway. Don't forget to like the video, subscribe as well for more of these. That'd be fantastic. VLSM will be up next, so stay tuned for that. Thanks for hanging around, guys. I'll catch you on the next video.